I started recording. Okay, you should see this red dot there, but maybe far away students don't see it. This red dot should be here. Okay, do you see it? Okay, so it is recording. That means that I missed the beginning of the course. Let me go back and okay, show it to the recording. Okay, this is what I said, the name of the course, my name, the Teams page. It has to be followed all the time. These are our course objectives. These are our textbooks. PDFs are available. We talk about those, and we talk about the course prerequisites, and we talk about the grading. And now we will continue with homework grading. As I said before, you will use our Teams system to submit your homeworks, and I will tell you that the homework is due that day, and you will submit it by that day. If you don't submit it, then you are late. For each day late, we will grade your homework in a deducted manner. If you are 1 day late, your homework will be graded out of 90. For 2 days, it will be graded out of 80, and etc. Okay. By the way, I mean, I ask you to submit homeworks, at least 75% of the homeworks. That doesn't mean that you should, you can submit a nonsense homework and count it as a submitted homework. Your homework should include some work, okay? Some considered valuable work. Otherwise, we will not consider it as a submitted homework, okay? It should include some significant work. So 1 line of code, 10 lines of code doesn't count as a homework, or meaningless code doesn't count as homework. After 4 days, we will shut down all the submission systems, and you won't be able to submit your homework. Okay, that's the rules for the homework submissions. These are the exam dates. I am planning to do the midterm exam at the 7th week of the semester. That will be on November 7th, Monday. But that's tentative. On the 1st of November or the October 31st or something, okay, we will make that decision 1 week before this date. I will ask you, should I do the midterm exam next week? And we will make that decision that week, okay? But that's why it is tentatively. Exact time will be announced after that. And the final exam will be, we don't know exact date for the final exam, but it will be on the 2nd week of the finals period. That's what I'm expecting, but this is not definite, okay? Approximately. Attendance, I had questions about attendance. This is not an online course. I expect you to come to the classes all the time. I will take the attendance, and it will be taken regularly, strictly. You are responsible from all the subjects covered in the class. Well, what did I say? I am trying to take a recording of this course while I am talking. But sometimes I forget. Sometimes other things happen. I don't know. Sometimes I may not do that recording. For that, don't trust my recording stuff or my YouTube channel. Okay. For that, you are responsible from all the subjects covered in the class. And by the university rules, regulations, you are supposed to come all the classes. But if you miss more than 30% of the classes, you will get a grade of NA from this course. Okay. So some people ask me, they work and they cannot take time off from their work to attend this course. But I mean, I don't know what to do. I mean, I work too, and this is my work. I have to come here and I have to teach you this stuff. I will have to take the attendance. Okay. Those are the rules. And announcement and the lecture videos, Teams page, again, all the announcements, either by the Teams page, okay, or in the class. I can make the announcement during the class, and I don't have to post anything on the Teams page. And you are required to monitor the Teams page and your emails too. Whatever your official email is, check your emails before coming to the class. As I said before, I will make these videos available on my YouTube channel. From time to time, you go there and maybe download those videos, or maybe if I can find where this is happening, maybe if I take this out, and directly, oh, that's why it is, this is short. We are back to the beginning. So there is a problem with this connector. Unfortunately, it's like this. Okay, so again, lecture videos. I am not guaranteeing that the videos will be there, but the thing is that I think I took these videos from last year and the previous year, maybe the previous year too. Those are kind of similar to what I am going to lecture this year, but every year things change. I may introduce some stuff, I may drop some stuff out. I don't know, so it is better to attend the classes and see what I am teaching for this year. Honor code, we have honor code. This one comes directly from the university regulations. If you are submitting something, it should be 100% your work, okay? You are not going to take anybody else's work and submit it as your work. Even a single line of code, single line of report text will be considered as cheating. Okay, the rule is if that homework or if that assignment is over 100 points, and if we think that somebody has cheated, we are going to assign minus 100 for the grade of that work. Okay, so be careful about this. Usually at this level, graduate level or the fourth year student level, we don't run into this kind of problem much, but these are the rules. We don't take cheating lightly, okay? So these are the stuff that we are going to cover, kind of the skeleton of the course. We will talk about morphology. Morphology is the study of the words, okay? There is a root of the word, and there are prefixes and the suffixes of the words, and the study that works on this word structure is called morphology. Then we have the language models. We will try to mathematically, or in software wise, we will try to make a model of languages, Turkish or English, okay? If I have a model of okay, let me talk about the models a little bit. Somebody said that I have a number of rules for the motions of the objects, right? That guy is Newton. He said that one of the rules is this. Okay? If an object has mass of this much, and if it is accelerating at this rate, to do this, you need a force of this much. That's a rule that he modeled the motion of the objects using this simple rule plus some other rules too, of course, right? This is a mathematical model for the motion of the objects. Using this model, people have developed lots of machinery. For example, our modern day cars, they use this rule, that they use this principle a lot, because this model works very well for many things on this earth. It doesn't work very well for the very large objects such as the galaxies and the stars and the other stuff, large stuff. It doesn't work very well for very small stuff like the quantum particles and etc. But it works for a wide variety of objects. It's a very nice model. We are not saying that this is the ultimate truth of the object motion, but it's good enough, okay, to be used for many things. We will try to do the same thing, okay? We will try to do the same thing for the language models. For example, what did they say? It said that, okay, if you apply a force of this much to this object, you will get an acceleration of this much, and that acceleration will cause this much speed, and that much speed is going to give you a distance of this much, okay? These are all results of this nice model, okay? I can, without making an experiment, without making that motion in the real world, I can guess these kind of stuff from this model. And we will try to do the same thing with the languages too. For example, we are going to ask questions like a function. We will write a function. It's called is Turkish. Okay, a sentence. Ben kitap okurum. Okay. So this function includes a model of Turkish inside it. It's going to return a value to us. It says that maybe that value is between 0 and 1. How Turkish this sentence is, okay, it's like a probability. Okay, how Turkish is this sentence? 1.0 means that I am definitely sure this is Turkish. 0.0 means that no, it is not Turkish, okay? So I defined a probabilistic model for Turkish. And you might be wondering how we are going to do that. We will see. And we have very nice and very simple ways of modeling Turkish or English or any other language like this. Okay? So we will be talking about this was a statistical model of Turkish. There are other ways of modeling languages, and we are going to talk about it. Part of speech tagging is for a given sentence, for example, this one. Ben kitap okurum in Turkish. Okay. What kind of function does this word have? Ben, okay, or kitap. Is this a noun? Is this a verb? Is this an adjective? And etc. Okay. Sometimes, for example, I mean, in English or in Turkish, you cannot know the type of the word by looking at it only. A word could be sometimes a verb or sometimes a noun, sometimes an adjective, okay? It depends on the function inside the sentence. So that's called part of speech tagging. That's one thing that we are going to look at. Classification is another thing. Given a sentence, for example, this is a very typical example for the classification. Okay, for example, a tweet. Somebody tweeted a sentence about Gebze Technical University. The tweet says that I like Gebze Technical University. Is this a positive tweet or negative tweet about Gebze Technical University? I need to make a decision. Okay. Well, you might say that this is a very trivial thing. I mean, somebody says that they like Gebze Technical University. It's a positive thing, right? It is easy to know. But the case is not that easy all the time. It might be a sentence something like Gebze Teknik Üniversitesi'ni sevmek isterdim ama bu hocaları yok mu? Is this a positive or negative sentence? It's a difficult one to decide. by looking at just individual words, right? You need to know Turkish, you need to know maybe the modern ways of using Turkish by the Generation Z or something like that. So classification is not an easy thing to work with for the natural language processing. Hidden Markov models, this is just a strictly, maybe you know about it, we will talk about it. It's just a model to model stuff, continuous stuff, or the sequential stuff. Constituency parsing, when you say an English sentence should consist, should be composed of a noun phrase and verb phrase. Noun phrase could be as simple as a simple noun. For a pronoun, for example, I. I is a pronoun, zamir. Okay? It could be I, and this one is go. I go. Okay? It's a simple English sentence. But the English sentences are not always as simple. But the rule always applies. There is a noun phrase and verb phrase. The three guys who are standing by the sidewalk decided to go backwards. Okay? So the noun phrase became the three guys standing on the sidewalk. It's a noun phrase with a relative clause in it. And the verb phrase, includes some transitive verb, decided to go backwards. Okay? So this is called constituency parsing, giving some kind of a hierarchy for a given sentence. Doing constituency parsing for English or those kind of languages is easier than doing it for the Turkish language, because for the Turkish language we call it more like a sequence independent languages. You can change the order of the words, the sentence is still valid. Ben onu gördüm, gördüm ben onu ben gördüm, gördüm ben onu, gördüm onu ben. These are all sentences that we use from time to time, and their meanings are different, right? So I can change the order of the words, and they still mean something, and their meaning changes. So doing constituency parsing on languages like this is not that easy. For English it is better. That's why we have other types of parsing, dependency parsing. Okay? Dependency parsing says that, if I am going to parse a sentence, Turkish sentence, I don't pay any attention to the order of the words. For me, the important thing is there should be a verb field inside a sentence, and there should be a subject of the sentence. Maybe there is an object, and there might be some adjectives or adverbs that are modifying those verbs or the nouns and etc. This is called dependency parsing without paying attention to the order of the words. So we will look at both of these two types of parsing. The programming languages that we use, the keyword ordering is very important, right? A C program should include a running C program, and executable C program should have this somewhere. It should definitely say integer and main. For this part it can change the parameters, and inside it there are many things that can happen, but using the constituency parsing and that kind of word order dependent parsing, I can parse these kind of languages, and I know that there is no ambiguity. It means always the same thing. It doesn't make any sense to do dependency parsing for these kind of formal languages, but it is very useful for languages like Turkish. Co-reference problem happens a lot for most of the languages, human languages. What is coreference? Telefonu cama attım ve kırıldı. When I say telefonu cama attım ve kırıldı, I throw my phone to the window and it broke. What does it refer to? To the window or the phone? Which one? Phone? Window? Well, if I told you this sentence maybe 40 years ago, it is definitely the window, right? Because the phone, cell phones especially, used to be this big. And when you throw a cell phone to the window, this big, it doesn't break it. If I told you this sentence 15 years ago, the cell phones used to be smaller and smaller. Remember those very, very small? It used to be better if your cell phone is small, right? In that case, maybe your phone broke. Nowadays, I don't know. So, I mean, coreference is what do I refer to with that pronoun there, okay? Anaphora coreference solution. Why do I need to solve it? Because without finding what that it refers to, I cannot translate it, right? I cannot do the machine translation, okay? Machine translation is maybe the most popular topic of the natural language processing, okay? So I'm not going to talk about these last two topics, but you understand what we are talking about, right? So basically, it will come to this, okay? When you do the NLP, usually we are talking about the information extraction, machine translation, summarization, okay, question answering, etc. If we achieve some of those things that we are going to cover for this semester, okay, our job to address these problems will be easier, okay? And whenever needed, when we look at all these problems, nowadays, natural language processing uses this deep learning technique and machine learning technique. So most of the time, we will come back and we will talk about machine learning or deep learning. So maybe next week or the other week, I will start talking about machine learning, neural networks, deep learning systems, and etc. And from time to time we will come to this. But I like to do two things at this course. One is the classical way of looking at stuff, okay? Classical natural language processing. By classical I mean the natural language processing people used to use in 1980s and 90s, okay? Starting from 2015, okay, things changed a lot. Nowadays, most of the stuff that works with the natural language processing is deep learning, and we will have to look at this deep learning stuff too. Okay, so basically that's the introduction to the course. Are there any questions so far? Where is my attendance sheet? Attendance? Did everybody sign it? Okay, good. Any questions?
So I have one. You said each day of late homework delivery 10%.
10% off, yeah.
Deducted. So if I get 60 one day later, will it be?
Well, I mean, one day late, your homework will be graded out of 90. Okay. So you are going to, if you are getting 60 out of 100, you are going to get 50. Why are you asking these questions? Is that the? Yeah, but don't try to be late. Okay. Do it on time. I will give you enough time. Okay, good. So if there are no questions, let's take 10 minutes of break. After the break, we will do the real lecture. I will try to make these slides available on our Teams page. I think the introduction is available right now with the syllabus. Okay. And in the second lecture, I will do the introduction. Okay, 10 minutes of break.
Sibel Hoca size ulaşmaya çalışıyordu da.
Aha.
Çalışıyormuş daha doğrusu bana söyledi. Haber geliyordu. Hatta bizim bölümün girişini gördüm. Yusuf Hoca nerede diye sordu. Yusuf Hoca derste işte.
Hocam kusura bakmayın.
Yoktu ama altına yazabiliyor muyuz?
Yaz ama yani bunu ekletmezsen birilerine kaydın olmaz.
Ya çıkarda şeyde alacağım hocam.
Tamam, iyi güzel.
Yazabilir miyim? İmza atmak için.
Yaz tabii.
Hocam ben de farklı sınıf yazıyormuş da ben de gidince çıkamadım derste.
Z11 ya. Nereye girdin? Başka sınıfa mı?
Z6 yazıyor hocam benim OBS'de. Ben de gittim oraya derse
OBS
gidince
ile okul
çıkamadım da
farklı yazıyor
dersten.
ya. Niye öyle ben de anlamadım. Sayfaya baksana.
Sonra.
Ya aslında buranın tabelasında da yazıyor EDZ6 diye de.
He.
Ne, hangi ders vardı orada?
Yazılım mühendisliği dersi vardı hocam.
Lisans dersine mi girdin?
Galiba evet.
İyi tamam. Göktürk Hoca'yı, Haber Hoca'yı tanımış oldum.
Hocam bir şey sorabilir miyim? Ders kontenjanı açılacak mı? Bilginiz var mı?
Mezuniyet durumunda olanlar için evet.
Ya özel olarak hocaya mı söyleyeceğiz?
Ha, hocaya gideceksin diyeceksin ki
Hocam mezun olacağım, bu dersi beni alabilir misin? Anladım.
danışmanın onu imzalayacak. Hani elle doldurulan form var ya. Mazeretli ders şu yönde yapabilirsin bence.
Ama öncelikle herhalde ders veren hocaya gitmem lazım. Sonra danışmana gideceğim.
Yok, danışmana git. Danışman senin mezun olacağını görüyor sistemden.
Tamam.
O dersi verebilir.
Tamam.
Öyle anlaştık yani.
Görüntü işleme dersi açılmayacak tamam hocam.
Görüntü işleme dersini esasla düşürmeleri lazım, indirmeleri lazım. O da niye indirmemişler bilmiyorum. Onu veren hoca ayrıldı ya. Bu dönem açılmaz yani.
Hocam, deep learning artık yapılabilir.
Ya deep learning yerine neurocomputing açıyorduk, kimse almamış. Neurocomputing'in içinde deep learning vardı. Deep learning de yok bu dönem.
Atanması gerektiği için mi diyorsunuz?
Benim oradaki danışmanım bir konu üzerine çalışmamı istiyordu. İnsanlarla aşırı üzerine. Onunla sanırım böyle bir proje var zaten. Bakmıştık o doktora tezlerinden bir tanesine benim hocam, ben danışmanım oradaki bölüm başkanım. Ben habersiz bir şekilde Yusuf Hoca ile iletişime girip bu konuyu çalışacağız. Ben işte danışmanım falan bir şey yazmış. O yüzden zaten direkt hocaya tanıştım ama dedim hocam hani benim haberim yoktu böyle bir durumda. O konuyu ben hiç bilmiyorum çünkü.
Karar verilmiş.
Biraz öyle oldu. Hoca da tamam hala emin değilsen bir hocalarımızla falan dedi.
Senin kafanda bir şey olmadı.
Yani henüz yok. Ben zaten daha yeni yüksek lisansa gidiyorum.
Bu ilk doktorun.
Evet. Hocaları inceliyorum. Evet güzel konu, bir şey demiyorum ama hiçbir şeyim yok yani. Öyle hatırlıyorum.
Background olsa biraz şey yapıyorum.
Siz ne çalışıyorsunuz?
Güvenlik çalışıyorum ben şu anda zararlı yazılımlar üzerine çalışıyorum.
Hangi hocaydı?
İbrahim Hocam. Yani zaten geçen hafta yoktu sanırım.
Yok ben daha ilk kez bugün geliyorum.
Bugün de yok zaten. İstemişti dersten kaçtı. Bölüm sayfasından bakarsan programı orada olması çünkü aslında muhtemelen oradakiler uyuşuyor ama OBS'de Z06 dedi. Z11. Karışıklığı olmaması için bölüm sayfasında programı
uzun boylu, temiz yüzlü bayağı.
Beraber çalışıyor musun?
He, olur.
Tamam bir şey yapacak.
evet. Yani daha doğrusu lisansüstü öğrenci paper sunacak. Yani işte dersle alakalı bir paper onu anlatacak. Kodla implementasyonu yaparsak da
Yani anlaş.
ama onu yapmak zorundayız.
Biraz da zor ama yani muhtemelen
Herkesin etkisi %10'muş ama işte zorunluluktan başlamıştı.
valla ekşide yazık istemez. Çok zor yazıyordum. İki başvurum oldu yüksek lisansta. Gebze teknik alınca bir yerden çok şey yapmadım.
Yüksek hazırlığa girmişti. Bayağı inanılmaz zordu yani. Ama İstanbul'da daha kolaymış. Geçti ama yani hafta sonu falan yoktu benim için.
Senin lisansın bilgisi yanında uğraşıyor musun?
Yazılımcıyım ya, evet.
Çünkü ben bayağı bunlar
Ya zor, çok ödev veriyorlar ya. Yani ben bilmeme rağmen ya normal yapıyorsun zaten bir hafta sonu gidiyor yani. Sonra dayanamadım baktım.
Bilinç var mıdır böyle bir
Herkes artık oldu. Kime sorsun? Yine geldik. Şaka. Gelecek hafta falan.
Uğraşmadık yani. En son bir proje verdi. Orada baktık, bizim de biz attık.
Proje yaptım ama böyle bir şey yok diye.
Emek vermiş çocuklar.
Acaba sen de bunu verirsen.
Yani bir 10-15 daha.
Bir şey kalmadı ya.
Okay, these are slides from the book, Jurowski and Martin's book. I modified them a little bit and I made them available on our Teams page. Okay, so natural language processing. We are going to see what goes into this natural language processing. I mean, what is text processing? Text processing is loading a text, making a search in it, making some changes, etc. Natural language processing is similar, but many things we can do with the natural language processing. Whatever the humans are doing with natural language, okay, we try to communicate our ideas with the language. We try to reason with language. We try to summarize stuff. We try to translate stuff. Whatever we do with our language, we will try to do the same thing with the computers. That's the natural language processing. Okay, useful and interesting task involving human languages. The second thing is that we are not going to be very concerned about this, the second one, but the book says so. While we are doing this, maybe we can understand the human processing of the language too, okay? Because that's not something solved altogether. We don't know how the human brain works when it uses the language itself. So we are kind of concerned about that too. From time to time, we will come back to the second topic, but our first priority is the first one. Let's try to do whatever we are doing with the language. We do the same thing with the computers. Okay. Why should we care? Why are we taking this course? What are the things? Okay. The many trends. 3 of them are here. Okay. We know that everybody. Okay. We're coming. We know that many people they don't use pen, pencil, paper anymore. They use computers to write their ideas, to communicate to other humans. Okay, whatever they do with the language, most of the time instead of speaking, instead of writing it on paper, they just use computers. So human-to-human communication is now mediated by computers, okay, by email, by WhatsApp messages, tweeting, and etc. Okay, so that means what the data is already there. Why don't we use computers to make that data more valuable? That make that data more accessible to the computers. Maybe we can help them. Okay, and the other thing is that whatever is written, they are written through computers. Okay, so most of the stuff, more than 95% of the stuff, if we are writing them, we are writing using computers. And on top of it, whatever had been written from the beginning of the history, they all scanned and they all translated to the computer manageable data. So they are all available as data to us. So the data means money, right? Data means resource. Why don't we use this data to make more money on them? Okay. And maybe another thing is computers started communicating with the humans using the human language. Okay. Conversational agents. We are talking to the computers most of the time. We ask them questions. They give us answers in terms of human language. Okay, when you ask a question to Google, it doesn't give you just a single. Where is my glass? I forgot my glass. Okay, I have many backup glasses. So if I ask a question to Google, am I connected? Yeah. So what is big endian? I don't know why I asked him this question, but so it is giving me both the website that defines big endian. Also, it gives me a sentence that says big endian is an order in which big end. 216 ne elinde? Şeyler satıyorlar. It says that big endian is this. Okay, so it gives me the definition too. So it reads the whole thing, it finds the definition, and it gives me the definition. Even in fact, if I go to that page, if I go to that page, it modifies that page. Where is it? It underlines it. Couldn't find, so I didn't find it here. Usually it underlines that sentence that say that here is your sentence. So it is kind of, I am asking a question to a human being, okay? It gives me an answer in terms of human beings, okay? This would be a sentence that a human being can give to me. Or it just says, you asked me this, but maybe you want to ask the other questions too. So back the second trend, okay? Human-computer communication is happening like human-human communication, and the other side, the computer is behaving like human. We kind of like it that way, okay? Previously, like maybe 5 years ago, right? When I ask the same question, I just get the website name, right? I click on it, I search for my answer. Nowadays, I am getting complete sentences, okay? And we are not far away. Note that this is not an original sentence, right? This is a sentence from this website. It just makes this big Indian definition, okay? We are not far away from Google making a summary of a nice definition of big Indian, okay? And that would be an original sentence. There is no reason why we don't have an original sentence from Google. It says that I read many websites, I read many books, and I'm making a definition for you for the big Indian. Okay, and these are my references. So we are not far away from this from being happening. I'm sure they are working on it. I'm sure there is a system that works 95% of the time, maybe 99% of the time. For that last 1%, they don't want to risk it, okay? So that they don't make this available. So very useful technology. So why don't we use it? We should use it. So conversational agents becoming more and more common. Maybe you might say that this is just a single question and answer. If I am in a conversation with a computer, when I ask this question, what is big Indian? It gave me a definition of the big Indian. Then I would ask another question about big Indian. So what is the advantage of it? Okay? When I say what is the advantage of it, of course as human I mean that what is the advantage of using big Indian in microprocessors, right? That's what I mean. So it should know that I'm in a conversation. I am referring to the big Indian, usage of the big Indian in microprocessors, right? So it should give me an answer by looking at the dialogue, okay? Not just a single question and answer, but many questions and many answers depending each other in a dialogue, okay? So these kind of things are possible too. Okay, so if the technology is available, people will try to make lots of money. Google is always into this. Facebook is always into this. Many other companies are always into this. I will skip this part. Google Translate is along with the other translation systems. It started working very well for the last year actually. After the takeover of the deep learning systems, sequence-to-sequence translation stuff, unsupervised machine translation stuff, it became very well. It uses the nice words. I mean, nowadays the human translators, they work this way. They take the original text, they feed it through the Google Translate, and they make modifications on them. Because Google Translate gives you lots of, it picks very nice words for you, and if you understand the original text, the Turkish text or the French text will be very nicely modified. Okay, that's at least what I do. Okay, again, web question and answering. When you ask a question, this is an old one actually. This one comes from 2015 or 2012 or something like that. When you ask the question, what is the population of Boulder? Boulder is a city, okay. It gives you an answer like, but nowadays it gives you a complete sentence about the Boulder's population. Web log analytics, or the sentiment analysis of the web data. For example, scanning all the tweets about large companies or the universities like Gebze Technical University. I mean, it is very important for companies like Coca-Cola or Pepsi to see what's going on the social media, right? If some crazy guy said that Coca-Cola makes you cancer, I mean, people are always saying this kind of stuff, right? But if many people are repeating the same thing, you should know about this, right? So what are you gonna do? Either hire 10 people, 20 people to look for these kind of tweets, or you are going to run some kind of an intelligent system that scans all the social media and tells you this kind of stuff to the CEO of the big corporation, right? So political opinion mining, product marketing information, these are all done. As a political party, by scanning the social media, it is much more efficient or effective to know what party is going to get what kind of percentage of the votes for any part of the world. Okay, Facebook says that I know who is going to be elected from the social media messages, but I'm not telling you. Well, I mean, if Facebook tells us who is going to be elected, they cannot make money on it, right? Says that I know who is going to be elected. If you want to change it, pay me some money, okay? And I'm going to redirect people, making them believe that things are the other way, and etc. That kind of stuff. Okay, so these are very, very important stuff, not only in terms of money, but in terms of political scenery of the whole world, not the continents, but the whole world. We know from the Northern Africa or the Middle East, right? They can do whatever they want, whenever they want. They can redirect people. They can change their ideas, and etc. and etc. Okay, so these are all done through the use of natural language processing stuff. So let's come back to the real techniques that we use to do the natural language processing. These are all about classical language literature. We always know that you need to use the words. Okay, words are not simple; they are complicated too. So we are going to look at the words, okay, how they form. Especially, I mean, for English, words are not that difficult to understand. There is a word especially for the verbs, right? I mean, let's say the verb run. The run verb becomes runs. Sometimes it becomes running. And if it's a regular word, for example, walk becomes walking or walked, and that's it, right? There is nothing much, and walks, right? 3 forms of it. For languages like order is important. Words are not that complicated, but languages like Turkish, words are so complicated, okay? Because for languages like Turkish, our words can take lots of forms. When you say yürümek, starting from yürümek, you can make lots of yürüdüm, yürüdün, yürüdüler, yürüyormuş, yürüyormuşçasına, yürümüşlerdi, etc. So on the average, there are 5,000 different forms of a given word in Turkish, right? So the way these kind of things happen is much more complicated in Turkish than English. So depending on the language, the study area might be difficult, might be simple. So in our study, we will start talking about the words in the next chapter. Then we will go up one level and we will talk about syntax. Syntax is the rules that determines how the words come together. Okay. For example, English is a usually noun verb object language. I go to school. Okay, I is noun, go is verb, and school is the object. That's how English works. Ben okula gidiyorum. Noun, this is English, right? Ben okula gidiyorum. Noun, object, and verb is Turkish, right? So this order changes from language to language. That's what syntax is. Okay. I gave you very simple examples. Not all examples are this simple for English or for Turkish, but that's the meaning of the syntax. Syntax is how you order your words, whatever the structure word says. I don't care. Syntax talks about it. As I said before, Turkish is a fluent language. Okay, its word order changes a lot. For languages like English, the word order doesn't change much. Then we have at the one upper level, then we have meaning. Okay, semantics. The meanings of the verbs, words, nouns, they change the structure of the sentences. You can say, okay, I go to school, right? That's good. But you wouldn't say, I eat school, right? That doesn't make any sense. So the meaning of the words constrains you to construct some sentences, and it restricts you from doing some non-meaningful sentences. Okay, so that's the meaning. At the top level, we have the pragmatics and the discourse. Okay, discourse is the meaning of the sentence depending on the context. Bağlam. Bağlama bağlı mana. Okay? The meaning of a word is not fixed all the time. Okay? For example, in Turkish, atmak. I don't know how many meanings atmak has in Turkish, but there are many. Kafadan atmak, taş atmak, kulaç atmak, adım atmak. These are all each usage of this verb atmak has a different meaning, right? So it doesn't have a single meaning. Sometimes you get this meaning from the discourse, from the context. Whenever I use it, its meaning changes. Okay, so that's called discourse. And we are going to see natural language processing techniques at each level, starting from the words. And we are going to look at the words a lot. Then we are going to look at the syntax a lot for the meaning and discourse. I mean, in discourse, maybe I'm not going to look at them a lot, but we will talk about them. And then after that, we will talk about applications exploiting H. Okay? If you know your words very well, okay? If you know words very well, for example, if you know how the words are formed, if you know this one very well, words, then you can write a very nice spell checker, right? Spell checkers are about words. Okay? If you know your syntax, then your grammar corrector is going to tell you that you are using a passive sentence. Why not use the active sentence, and etc. Okay? If you know about these meaning and discourse, then you are on your way to a very nice machine translation system. Okay? So whenever we study any of these levels, okay, after the study, during the study, we will look at the applications one by one. Okay, good. You might say that what's an NLP application? If there is an NLP application about the words, how about this? I like to count the number of words in a given text. is an NLP application. Okay, given a text, okay, an email, I like to count how many words there are. Is this an NLP application? Then somebody says that, why don't you use the Unix utility WC, word count? Do you know this WC? Let me open up my fake Unix interface. Yeah, WC menu page. It says that I can count, okay, in a given file I can print the number of words, number of bytes, and etc. Okay, so is this an NLP application? We keep using this WC T2TXT. It says that, I guess it is 11 lines. I don't know what is 11 and 13, and I think it is 103 characters, 13 words, and 11 lines, something like that. It gives me this statistics. Okay, is this a NLP application? Can I say that this is an NLP application, like an application about the words? Well, it's a tricky question. Usually we answer this question, okay? Usually we answer this question, okay? If it counts the words, yes, because word is the building block of the natural language sentences. So when it counts words, yes, but when it counts lines and bytes, no, it's not a, because those are not linguistic entities. Okay. So it's a small example about what can be considered as an NLP application, what is not. Usually, I mean, as I said, this is a very simple case. Usually, there is no confusion between it's an NLP or not. If it's an NLP application, then it's a case for the artificial intelligence. For any artificial intelligence application, usually, most of the time, we don't know the definite answer. We are not 100% sure about the definite answer. I will give you, for example, I will give you a text. The Turkish law, okay? That the book that this take, or it is maybe too complicated. Let's go to our university's homepage or our departmental homepage. There is a text here, okay, this text, okay, and I will ask all of you to translate this text from Turkish to English, okay, and you are all very good English speakers, okay, you studied English a lot, you are going to translate it. So how many people that are in this classroom? 50 people. I bet there will be 50 different translations. Which one is the best one? We don't know, okay? Who's going to make a decision? You might say that whoever is the best translator, Turkish English translator in this world, let's ask him or her, okay? But there will be many good translators between Turkish and English. They will do the translations differently, okay? So my point is, in terms of machine translation, there is no best translation, right? You might say that this is good and this is good and this is good, and you cannot say that this is the best one. So why are we talking about this all of a sudden? Okay, we are talking about this all of a sudden because, remember, we like to recognize if a given application is an NLP application or not an NLP application. So if it's an NLP application, usually you don't know the definite answer to the question. So do you think when I give you a text, like a file, if I ask all of you how many words in there, would you give me the same answer or different answers? Most of the time, for most of the cases, word is a word. But sometimes, for example, in English, when you say aren't, is this a one word or two words? For some English people, maybe it is one word, maybe it is two. Right? Depends on who makes the rules, right? In Turkey, this Türk Dil Kurumu, they make the rules, but they keep changing their minds, right? I mean, sometimes they say that these words are going to be written together, or sometimes they will be separate, and etc. So it changes from time to time. So this word count might give me different answers depending on the rules, and if the rules change, the results will change. So that makes the typical NLP application. We don't know the exact number, but we can compare it. Let's say I ask 5 different experts to count the number of words in a given text. One of them said 500, the other one said 502, and the other one said 505. If my automated application says 502, 3, 4, 5, I am good enough. But if it says 200, then I am in trouble, right? Okay. So that's the kind of the way you make the separation. NLP is a sub branch of artificial intelligence, and if a problem is an artificial intelligence problem, most of the time you don't know the definite answer. What did I ask to Google? I asked Google what is Big Indian. It gave me a result, and it gave me the website, right? How do I know that that's the best result? How do I know that that's the best website that it can quote, right? We don't know. I mean, but it is good enough. I just immediately click on it, and it looked like I am satisfied. But if somebody is a very good expert about big endians and little endians and etc., okay, they might say that I know that website might contain errors from time to time. That's why I don't trust their answers, even though that sentence might be correct. For this question, I would quote some other website's definition. Okay, that might be a better answer. Again, I don't know. That's typical artificial intelligence problem. Okay, so when we come to big questions, this is more evident. What is the best summary of the novel War and Peace? Right? We don't know. I mean, even the writer of that novel may not summarize it in the best way, right? What is the best machine translation for a given text? What kind of an answer should I give you as the best answer? What kind of question should I answer as the best answer? These are applications of NLP, and usually for the artificial intelligence problems, you are satisfied when the result is good enough. We don't say it is perfect, we say it is good enough. What is good enough? If it is good enough for me, remember I clicked on the first one and I liked it, so that's good enough. Okay, so when the question answer, I ask a question to the robot, it gave me an answer and I liked it and I hang up the phone, that's good enough, right? Google gave me the summarization of Google gave me the machine translation of a text from English to Turkish, and I used it without any modification. That's good enough for me. Okay, so good enough is most of the time is our criteria. Okay, so let's look at some of the stuff that we talked in a real example. You guys know this movie 2001 A Space Odyssey? Yeah, well, it's a classical movie. It's from 1960s maybe. There is a scene on that movie. Let's go to that scene if my YouTube works. 2001 Space Odyssey. I'll open the door. Okay. For those of you who don't know the movie, this guy is in space with his smart computer. This computer can do NLP, of course.
Open the pod bay door, please, Hal.
Okay. This guy is out of the spaceship and he wants to get in, but computer thinks that humans are stupid. They are going to hurt themselves. So I should take control of this ship, and I am not going to take this guy in because they are error prone and etc. So this computer makes a decision, and this computer is not going to take that guy in. So this is the conversation.
Open the pod bay door, please, Hal.
He said, what happened there? Open the pod bay doors, please, Hal. Hal is the name of the computer, okay? Open the door for me. And Hal, as an Dave, I am afraid I can't do that, okay? It's a smart computer, it is giving an answer. And of course, it can understand the sentences, it can produce sentences. It is better than that, it can recognize speech. And it can produce synthesized speech too. So, what kind of technologies should we have to behave like Hal? Okay, it says, I am sorry, Dave, I am afraid I can't do that. Okay, so let's look at that. First of all, it needs to know, okay, how the speech is formed. It needs to recognize words from the speech data. So speech recognition and synthesis is something. Other than thing is that it knows, okay, once it recognizes the words, okay, it has to know the meaning of the words. What is door, okay, what is opening, and etc. And then it has to know how these words come together, syntax, okay. So these are the words, this is the syntax, how these words come together. The guy says open the door, it says that I can't do that, right? So when when the computer hears open the door, it has to know what is open, what is door, and the meaning of the, right? And it knows that it's not door open, it is open the doors, right? The door, the open doors, etc. We are not talking like that. It knows the syntax and it says that, okay, this is a valid English sentence and I understand the meaning of it. So we are not finished. The computer has to answer, okay? Well, if you are doing this English dialogue with a human, in English, you use these kind of phrases actually. You don't say no, okay? That's considered impolite. When you talk to somebody in English, either American or British or doesn't matter, okay? It is very impolite to say no. You will say, I am afraid, I can't, I think, etc. Well, I mean, the computer is a very bad computer actually. That computer is trying to kill that guy, right? Still, you have to say, I am afraid, I can't do that. Well, it's kind of, do you think that it can't do that? Of course, the computer can open the doors, but it says, I can't do that, okay? That's how English works. That's how English dialogue works. If you don't behave like that, you are not a very good English conversational speech robot, right? So that's what you need to know. The original question was this: if we are to build such a computer that can do the NLP, what do we need to know? Okay, our system should know about the words. It should know about the syntax. Also, it should know about the discourse, dialogue. Okay, under what circumstances I should say what? Okay, so in a conversation you have to be polite all the time, like the British. Even if you are going to kill somebody, okay, and you behave that way. I am afraid, I can't. The computer is not afraid, we know that, right? And the computer can open the doors, we know that too. As I said before, these are all problems with artificial intelligence. We deal with ill-defined problems. Ill-defined problem means that To solve the problem, we don't have all the things necessary for a definite answer. Most of the time for artificial intelligence problems, most of the time, we don't have the exact information. Information is either missing or it's noisy. Okay? And we should make our decision accordingly. And we don't often come up with exact solutions. Our solutions are most of the time approximate. As humans, we make decisions like that, okay? It is very difficult to walk, right? Using two legs and your arms and other motion, etc. And we seem to do walking very well, but do we walk optimally? When we walk, do we spend the least amount of energy? We don't know, right? And actually, I don't care. As long as I can go from this classroom to my office, okay, without bumping into anybody, without hurting myself, it is okay. So it is good enough for me, okay? I am not trying to walk in the perfect manner, okay? That's not achievable either, or it doesn't make much sense to achieve that either, okay? So that's typical of AI problems, and NLP is no exception. We try to do good enough. We try to do good enough. Okay, so in this course, our purpose is building those kind of applications that we talk about. For those, we need to know lots of stuff, okay? I know all of you have the computer science engineering backgrounds, but we are going to look at this linguistic stuff, okay? Dil bilimi, morphology, syntax, discourse structure, etc. These are the stuff that we don't know much, but this stuff we know. We know regular languages, we know context-free grammars, we know what dynamic programming is, we know how to design and how to implement algorithms, okay? Those are the formal systems. Then, combining these two ideas and whatever we know from the linguistics, we are going to build applications of NLP. And this course material is around this stuff, okay? I think we talked about this before. We will talk about the words a lot, okay? Then syntax, words, how the words are formed. For some languages it's simple, for Turkey it is complicated. For syntactic processing, how the words come together, how they lump together, right? Then the semantics is the meaning of the words in isolation, the meaning of a word in isolation. So the dictionary definition of a word, semantics. Then I have the discourse, the meaning of the sentences in context, okay? Then at the end we have the dialogue structure. What happens if I do all of this in a dialogue while I am in a social environment? I mean, it is perfectly acceptable for me to stand here and tell you all of this stuff because I am the instructor here, right? It is perfectly acceptable for me to talk to this much in a 3-hour lecture. But if any of you comes here and talks as much as I do, that would be weird, right? That's called discourse structure, okay? The type of sentences that I can use in this classroom is different than types of sentences that you use. You usually ask questions or make comments, right? You don't try to teach something to me. That would be very nice, but that's not our social environment right now. In our environment, okay, I am supposed to talk, and you are supposed to listen. That's the dialogue structure, okay? These kind of stuff are very important for the NLP systems. If you don't follow that, then you won't be that successful. Okay. What is Phobology is doing? He's letting them go early, 10 minutes early. I think he's starting early. Ders bitti millet. Ders bitti.
Çabuk çıkarsın.
During the weekend we had our graduation ceremony, and I didn't know most of the people that we have graduated, and I don't know any of them. This virus thing changed everything. Okay, so for this we are going to use lots of techniques. You know some of them. Finite state methods, you know them, right? Well, you are going to remember them. Context-free grammars. I don't think that I will talk about. I very much like to talk about it, but nowadays nobody is using the logic, first order logic. Okay, and I'm not going to talk about it. But during the 90s and 2000s, logic was the #1 technique used in natural language processing. Unfortunately, it wasn't that successful. We understood it when the deep learning based techniques came into play. But we are going to talk about these two. Okay, probability models we are going to talk about a lot. Okay, probability is, remember the AI systems? It's a very old paradigm. What happened to AI systems? Well, remember what I said about the AI systems. Most of the time we need to make a decision under uncertainty. Probability is very helpful in those kind of cases. Okay, in those kind of cases. Probability is my belief into something. Okay, I don't know that for sure, but I know that it is 80% correct. If I can formalize it mathematically, I can give you an optimal way. How should I behave in the real world? Okay, so that's the probability models. So I am going to give you, for example, I will define some. What is the probability that I read given that ben okurum? Okay, so I am trying to calculate the probability of this. Given that the Turkish sentence is ben okurum, what is the probability that the translation, English translation of it is I read? Okay, if I can assign a probability to this expression, and I can prove that somehow that I can rely on this, it is reliable, this is good enough, then I am almost done with the introduction of the machine translation, right? So probability is going to help me a lot. Remember, what did I say? There is no perfect translation, corresponding translation sentence. I can translate this in many different ways, but if this probability is good enough, close to 1.0, 0.95, then that means that this is good enough. I'm not saying this is perfect, this is good enough. So probability, I use probability theory, it's a very old theory, okay, in addressing in many of these artificial intelligence related stuff. And machine learning comes into play. Machine learning will make these kind of probability assignments a lot easier for me, because dealing with the probabilities, calculating those are not that easy. Okay, so some applications, from the simpler applications to the more complicated. Small applications, spelling correction. Okay, I wrote something. For example, I said GÖRDM. Okay, well, it looks like a Turkish word, but I think there is a letter missing. It should be gördüm, right? Do you think maybe gördü could be gördü, or I don't know. So spelling corrector says that, okay, this is not a valid Turkish word. I don't know this one. Did you mean gördüm or gördü? or something else, I don't know. Okay, so that's called spelling correction. It's a very small application. It has to know about the word structure of English or Turkish. Hyphenation. Hyphenation is how you divide a word between the lines. Ne diyorduk ona Türkçe'de ya? Satırın sonuna kesme. In Turkish, hyphenation is very easy. You can teach how to hyphenate words for a 7-year-old kid, but for English it is different because the definition of the syllable hece in English is very different. Do you know how to hyphenate a word in English? Well, most of the Americans or British, they don't know how to do it. It is difficult. You need to know the root of the original etymology of the word. Is it Latin or it is Greek or it is somewhere else, etc. That's why Microsoft Word it never hyphenates, right? It just puts spaces between the words. Word sense disambiguation is a medium level application. Word sense disambiguation is this: a word can have many different meanings. For example, it's a classical example: bank. Translated to Turkish, what is the Turkish word bank? Nehir kıyısı is one word, yes. Banka is another one. Oturduğumuz banka is another one, right? You could say many other things maybe, okay? Or banking my many. What is bank? Bir şey, bu iddia ile alakalı bir şey de bir manası var ya banking. If you look at the dictionary, it has many different meanings. So when you say bank, what is in a sentence? If you see bank in a sentence, which meaning do I mean? Okay, out of all the 17 meanings, which meaning do I mean? That's the word sense disambiguation. Named entity recognition, information retrieval, other medium level stuff. For the large level applications, question answering, conversational agents, summarization, machine translation. Of course, these are the applications. If you are successful on these, lots of money in there, right? Lots of money in there. Good. Okay. So categories of knowledge. Kind of talk about that, but since it's in the slides, maybe I should talk about it. Phonology it's about the words, but it's the sounds of the word. Phonemes, okay. How the sound waves come together to make a word. When we hear, we recognize it. Morphology is the structure of the words, the parts of the words, the root of it, suffixes, prefixes of it. Okay. Syntax, how the words come together. Semantics is the meaning of the words in the sentences. Pragmatics is the meaning of the words in a context. This course we talked about it. In a social situation, the meaning of the sentences changes, right? In a social situation. Okay? So, one important concept, ambiguity. Let me make a definition of the ambiguity, and we will talk about it in our next lecture. But in fact, in all of our lectures throughout the semester this year, we will talk about ambiguity. Ambiguity is something that we try to address in natural language processing. We will never solve ambiguity problem, okay? But we will try to recognize where the ambiguity is, and we will try to develop applications, develop techniques to address this ambiguity problem. So what is ambiguity? Muğlaklık. Ambiguity is a sentence meaning more than one thing is ambiguity. A word meaning more than one thing is ambiguity. A suffix meaning more than one thing is ambiguity. In Turkish, we have lots of ambiguity in terms of morphology. For example, arabaları. Translate this to English. Arabaları. Their cars. One thing, okay.
Cars, just cars.
Cars, yes. His, what?
Onun arabaları. His cars.
Arabaları.
Cars. The cars.
The cars maybe, yeah. Well, in English, sometimes you cannot. How about this? Halaları. Don't translate it, just say it in Turkish. Halaları, bir tane çocuğun halaları, 3-4 tane halası var. 3 tane çocuğun bir halası var. Genel olarak halalar denen şeyler şunu yaparlardan bahsettiğin halaları datif haline. These are all morphology ambiguities. Without the context, without the sentence, I don't know what this word is actually. Okay? So how do you solve the ambiguity? Of course, you don't solve the ambiguity by looking at a single word, okay? You need to look at the sentence. You need to look at the whole paragraph, maybe whole text. Sometimes you cannot solve the ambiguity at all. You leave it as ambiguous, right? You leave it as ambiguous. And we are going to talk about ambiguity a lot. But now I am going to take some break. Derse yeni gelen var mı imza atmayan? Buraya gelip imza atman gerekiyor.
Bu mazeretli ders kaydında sanırım öğrencileri siz seçecekmişsiniz. Hangisini ben şey yapacağım?
Yok, hayır.
Nasıl olacak? Kurul mu karar verecek ona göre?
Kime ihtiyacı varsa o alacak. Mezuniyet durumu varsa öğrencinin
Tamam.
onlara vereceğiz.
Benim var mesela, ona göre mi?
Evet. Danışmanın karar verecek ona.
Tamam.
İçine koyayım mı hocam?
Hı hı.
Yani binaların işte şeylerin tabelalarına baka baka gidersen görürsün. Merhaba, ne haber?
Selam hocam, iyi bir şey sorayım.
Ben de Yusuf Hoca sevmedim sınıfta, haberin olsun.
Yapabileceğim bir şey yok, başka sınıf yok çünkü.
Değişeceğim falan dedim. Ben de içimden dedim ki yani.
Nasıl değişecek? Yani değişsin, ben de isterim değiştirmek ama. Yani yapabileceğim bir şey yok.
Zeyon'a gidip kızacak diye bir an bekledim.
Nereye?
Zeyon'a.
Zeyon'a gitsin desin bizim sınıfımızın niye aldınız?
Onu bekledim ben.
Yani o zaman rektörlüğe falan söylesin yani. Burcu Hoca'ya da söyledim, sınıf az yani başka sınıf yok mu dedim. Valla dedim hocam, elimizdeki bu yani.
Burcu Hoca hangi ders için soruyor?
Tamamen. Ben yine de bir bakayım ama yok diye biliyorum.
Benim öğrencileri yaşayanların algoritmaları. Bir de hocam, algoritmaları. Altı bir hocamız vardı. Genelde gezmişim. Görece diyelim. Lisansta falan almıştım ben, biliyorum. Yani ben de aldım da algoritmanın önce farklı anlatıyorum. Ben bir diğer aldım mesela. Matematik gibi anlatıyorum. Birinden aldım. Bayağı iyi bir süre yaptım. Değişmiyor. Hangi açıdan baktığını görüyorsun. Bizim madenci. İkisini geçiyor çeviriyor. Yarın değil mi? Geçiyor çeviriyor. Anladım. Zor. Asistan işte. Evet, adı bile çıkmış. Orada ders seçimi yaparken doktora öğrencisi seçiyordum. En az 4 tane 640 ders almam lazım. Mezun olmak için. Ondan ama dönemden 4 tane ders seçmiştim. Programından seçmiştim. Toplam 7 tane alıyorsun. Sonra hoca değiştirmiş 3 tane seçmiş. Muhtemelen çok gelir diye düşünmüştüm. Ama yani sonraki dönemler için hani böyle bir boşluk bırak yani 600 dersler için. Hocam sen aldın mı bu dersi?
Yok, almadım.
Aldın mı?
Bilmiyorum. Bakalım hangisi. Güzel aslında da bilmiyorum, alabilirim aslında.
Neye kayıt yaptın şu an?
Ne?
Neye kayıt yaptın şu an?
OS var, bir de algoritma var.
Nasıl?
Bir de şey var. Bilimsel araştırma falan var ya.
Tamam.
O kadar.
Ama kaçıncı dönemde oldu?
Neyi bilimsel?
Fark etmiyor. Benim bildiğim.
Bu dönem aldım ben yani. Aradan çıksın diye. Bu dönem aldım. Ama tabii baştan almak daha mantıklı bence. En başta.
Şahsen daha çok bir katkısı olmadı o yüzden
Evet,
hiç fark etmedi yani. Ya da oraya gidene kadar kendim mi öğrendim? Ne yaptım bilmiyorum.
O da olabilir. Buradakiler biyolojiden aldım ben.
Nerede onun biraz ya?
Karşıda
kütüphane
hemen,
üniversitesi.
karşı tarafta. Orada bina.
Elektroniğin şeyinde mi karşı tarafında?
Buraya elektronik, o karşı tarafta.
Bazı yerlerde hocanın bir sistemi oluyor. O sistem var. Yani tek hoca şu an sınıfta böyle.
Mesela ben de bakamıyorum dersleri. Yani dersten bazı derslerin labı oluyor. Labları da kapmış yapıyoruz. Güzel olduğumuz aslında. Bazı derslerde de bir ek piyas aslında yapıyoruz. Psikoloji çalışmaları var. Onları almak için de bunlar asistanlar yapıyor. Ama her derste olmuyor yani illa öğrenci buluşması yapmak için. Özel falan yapamayız. Asistanlar yapıyoruz. Ama yani ben şu kişinin danışmanı sadece onun dersini istekten geçiyor.
Boşluk var mı? Önüne oturmasın.
Şurada bir arkadaş var ama burası boş.
Ben de kaldım. Sınıfların maalesef.
Burası iyi de yani.
Evet, Probabilistic gene iyi yani. Bilerek zemin zaten buraya verdim.
Yani lisans zaten 45 kişi kaydediliyor.
Evet.
15-20 kişi de lisans
Kesiyor zaten. Sıkıntı şeyde çıkıyor. Z10'u aldıkları için sıkıntı orada çıkıyor.
böyle bir şey. Projektörü falan beğenmiyor. Ben kolay olanı yapmışım programda. Yarısı online olanı.
Evet. Online'cılar iyi.
Siz online yapıyorlar herhalde.
Neyse, yoğun derslerin hepsi. Bütün derslere sınıf verdim ben.
Ben de vermiştim.
Yani mesela yarı online gibi yapıyor. Olsun. Evet hocam. Sonra zor uyandım. Biraz olsun. 8.5 lira aldım. Zaten çıkıp gerek anladım. Zor tuttum. Hiçbir boş ver. İzleyip öğleden sonra gidelim. Dersten aldım da. Ses çalıştım ya aslında. Sen böyle çok şey yapalım. Benzer konusunda. Time series ikisi de. Benzer algoritm şeyler kullanılır.
Tamam, bir şey sorayım. Çok seçeneğim yok.
6.9 ders olmadı şimdi. 619 var. 626 var.
Bir Erkan Hoca'nın dersi olduğu için çalıştım. Sembol Competition var. Yani 3 tane vardı.
Merhaba sandaşlar varmış. Gökhan Hoca'yı sınıfta dersen 6.9 var.
Bayağı farklı şeyler.
Ben önce bir normal algoritmayı alayım da onu diğer dönem
O camı tam açabilir miyiz arkadaşlar ya? Okay, let's look at this ambiguity thing more carefully. As I said, we will talk about ambiguity all the time. Where are my, this is a new interface, annotations, clear all. Okay, so let's play the same game again. Translate this sentence into Turkish. 5 times. I need 5 different meanings. I made her duck.
Çömelmesine sebep oldu.
Çömelmesine sebep oldu. Tusturdum onu. Tusturdum. Bir şey yaptım kafasına, tustu. Başka? For more meanings. Onu ördek yaptım. Kafasına sihirli denekle vurdum, ördek oldu değil mi? Onu diyorsun. Onu ördek yaptım. What else?
Onun ördeğini yaptım.
Onun ördeğini ben yaptım. Onun ördeğini ben yaptım. Ben onun ördeğini yaptım, onun ördeğini ben yaptım birbirinden çok farklı değil mi? Okay, onun ördeğini, what else? Ona ördek yaptım yemesi için. Ona ördek yaptım. Anyway, I mean, maybe we can find many other meanings too. Okay, 5 of them. Well, it is easy to tell the different meanings of the same sentence if you translate it, because the ambiguity in English and ambiguity in Turkish, it doesn't have to be the same ambiguity. Okay, in Turkish, our ambiguities are usually around the words because the word structure is more complicated in Turkish. In English, the sentence structure is more complicated. Ordering of the words are more complicated. Okay, but both of them are natural languages. They are equally powerful. Ambiguity is part of life in all the languages. So what we mean is that ambiguity is always there. You cannot avoid ambiguity. Ambiguity is power of the human language, natural languages. You cannot avoid it. You have to live in this world of ambiguity. Okay? So I think it is 5 different things. I cooked waterfall for her benefit. Yemesi için ördek yaptım ben ona, değil mi? Ördek yaptım ona. I cooked waterfall belonging to her. Onun ördek yemeğini ben yaptım. Değil mi? I created the dog she owns. Ona alçıdan ördek yaptım. Oyuncak ördek. Tusturdum. Kafasına sihirli denekle vurdum, ördek oldu. Okay? 5 different meanings. So the different meanings come from, I mean, you can have the same type of ambiguity in Turkish. English is no exception. But let's look at why we are having all these kind of different meanings. One of the problems with is her, because the meaning of her is two different things in English. When you say, let's look at this one. Okay. Her can be possessive or dative. Possessive, iyilik hali gibi, onun ördeği. Or dative, ona, hali gibi değil mi? Ona, ismin hali. Bir de i hali var. İngilizce'de in English, there is a difference between him and his, but there is no difference between her and her, right? There is one her. The possessive is her, dative is her, but for males, okay, for muscular, we have his for possessive and him for dative, right? For the accusative i hali, it's the same thing. In Turkish, for accusative i hali, we have ördeği, ördeğe, I think in Turkish there is a ambiguity between possessive and accusative, right? İ haliyle possessive ördeği ve ördeği gördüm, onun ördeği. Anladınız değil mi? 2 farklı şey bunlar. Birisi i hali, birisi iyilik 2 i.
Ördeği ni.
Onun ördeği ama.
Ördeğin
Ama oradaki i hali değil o. Posesiften geliyor. Ördeğini gördüm olur. Bu ne? Onun ördeği bu. Ördeği. Bu ne? Ördeği. Ördeğiyle beraber geldi. Ördeği diyorsun. O da posesif. Türkçede de var yani. I bet in German they are different, but German is a different language. Whatever. So lexical category, there is a lexical category ambiguity, and there is a lexical category ambiguity in terms of meaning, semantics, because dog can be a noun or verb. Okay, if it's a noun, it is ördek dog. If it's a verb noun, then tusmak verb, right? And then what else? Made. In English, we made for many different purposes. Sometimes make is create, sometimes it is cook, right? So I cooked duck or I made duck is the same thing. Or I created a duck or I made a duck is the same thing, right? So many causes of ambiguity, and this kind of ambiguity is in all the languages. You cannot avoid it. We don't try to avoid it. We want it because if a language is ambiguous, that means that I can say the things that I like to say in a very small number of words, right? Very short sentences. That makes the language more powerful. Okay? It makes the language more powerful. I am producing a small number of signals, and the other side just understands me. I can do the same thing with the programming languages. Why? Because a program cannot be ambiguous. When you write a program, the compiler has to understand the same thing. There is no context in a programming language, right? When you say, for example, in C++, if I have a function that takes an integer, another function that takes a short integer, and when I send a character to it, okay, I can convert this character C to an integer or short, okay? Only these kind of situations the compiler tells me that, okay, but this is ambiguous, I don't know which one to call, right? I cannot resolve the ambiguity, but if I do this 12, well, I know that this is an integer, it's not a short. This is how the C language is written. So, in programming languages, in formal languages, there is no place for ambiguity. Ambiguity is bad. That's why our programs are very, very long. Okay? To express a Turkish sentence or English sentence, okay, when you say ikinci dereceden bir denklemi çözmek için şunu yaparsın, define an algorithm, but writing the code for the same Turkish paragraph takes lots of more lines of code, right? Because especially if you are doing this in assembly, because there is no place for ambiguity. The power of the language is always fixed. Whatever I can express in assembly, okay, you cannot exceed the power of assembly. And your statements are as long as them assembly programs. And there is no way to avoid ambiguity, so we have to address ambiguity somehow. Okay? By the way, these are all ambiguities about the word level ambiguities. How about the grammar level ambiguities? Remember what is grammar? Syntax? Syntax tells you how the words come together. Okay? So, how the words come together depends mostly on the verbs. For example, make can be a transitive verb. Transitive verb has a direct object. Make something, okay? I make food, okay? This is a transitive version of the word make. Or it could be detransitive. It has two noun objects. I made her, okay? I made her do something. Okay, that's the detransitive version of the word make. Or there is a action transitive. I caused her to move her body, right? So that make can be used either transitive or detransitive or the action transitive. Depending on how you read your sentence, it could mean any of those. Okay? And if you have two causes of or three causes of ambiguity in a single sentence, if you take the combinations of those, a sentence can produce many ambiguous sentences. And by the way, I think we will come back to this example a lot. I made our doc. Also, this is a classical example. I saw a man with a telescope on a hill. I saw a man with a telescope on a hill. Okay, this is a ambiguous sentence. If you like to translate this to Turkish, translate this to Turkish.
Teleskopla tepedeki bir adam gördüm.
Teleskopla tepedeki bir adamı
bakarken
gördüm. Tepedeki teleskoplu adamı gördüm. Tepeden teleskoplu bir adamı gördüm. Tepeden teleskopla bir adam gördüm. So it looks like on a hill. Am I on a hill or the man is on a hill? Two meanings here. With a telescope, I am with a telescope or he is with a telescope. Two meanings here too. Right? So there are four meanings. Okay. And I think there was a very nice I saw a man with a telescope. Let me show you. Yeah, this is good. So how many meanings? 1, 2, 3, 4, 5, 5. So each one has a different Turkish, right? This one is, we didn't differentiate this one.
I am with telescope.
Yeah, I am with telescope.
Here also.
Bunun Türkçesi ne? Teleskopla,
Tepede teleskoplayken.
teleskop yanımdayken bir adam gördüm. Tepede teleskoplayken bir adam gördüm. Okay, so that's another one. How about this? Oh, okay, this one, yeah, okay. I think two meanings converge here. What is the difference between this one and this one?
Teleskop ve adam. Ayrı ayrı.
Birisi teleskop, teleskoplu adam, teleskoplu adam, teleskoplu adam. Anyways, okay, I think you all agree that there is ambiguity with human languages, and it has to be there. Ambiguity could be at the, and we will come to this example a lot. This I saw a man with a telescope, and that happens a lot in English because, as I said, English is more powerful. English is more powerful in terms of its syntax. Okay, many rules about the syntax. Okay, many things are communicated through the changes in the syntax. In Turkish, the power comes from most of the time morphology. Okay, we play lots of morphology games when we do the for example, we laugh at stuff, right? When you mean something, okay, if I tell somebody a sentence, I mean this, but he understood this, for some reason we laugh at it, right? We say that it's funny. They understood me wrong. In English, they make those kind of jokes by playing the syntax ambiguity stuff. In Turkish, usually we do it with the morphology part, with the play with the words itself. Okay, but ambiguity is there depending on your languages. It might be in different places, and we even didn't talk about the phonetics. Most of the time we make these kind of assumptions. Read these sentences silently. Read them. whisper them, only you can hear. Okay, I made or dark, I made or dark, I made or dark, I made or dark, I made or. They all read like I made or dark, right? But they are all different words, right? So phonetics is much more ambiguous than the syntax level ambiguity, morphology level ambiguity, or the dialogue level ambiguity. Usually our Karagöz Hacivat, their ambiguities are at the phonetic level, right? Hacivat şakası söyleyin bana bir tane. Yanlış anlar ya hep Karagöz Hacivat'ı. Bir şey söyler, ben böyle anladım der. O da onun kafasında var. Bilmiyor musunuz ya? Genelde phonetic level ambiguity yaparlar onlar. Biz de güleriz öyle yapınca. Daha yukarıda yapmaya başladı. Buna çocuklar daha çok gülerler. Büyükler gülsün, 70-80 yaşındaki adamlar gülsün diye de semantic level ambiguity yapmanız lazım. Adam bunalımda falan filansa da güldüremezsiniz. Boşuna ambiguity ile falan. Uğraşmayın.
Ağlayan adam filmi var. Çeviriyorlar.
Kim, Charlie Chaplin miydi? I never understood that scene actually. Okay, so how do we deal with ambiguity? We deal with ambiguity in many ways. Let me start from the most common way of dealing with the ambiguity. Don't do anything. Maybe it won't matter. Okay, don't solve it. Okay, let's get to the example. We will leave when the duck is ready to eat. Translate to Turkish. We will leave when the duck is ready to eat.
Ördek yemeğe hazır olduğunda çıkacağız.
Ördek yemeği hazır olduğunda çıkacağız ya da ördek hazır olduğunda yemek için. Bir canlı ördek var, yemeğe hazır olduğu zaman çıkacağız. Ya da ördek piştiği zaman çıkacağız. Now the second sentence comes. The duck is ready to eat now. Doesn't matter if the first meeting or the second meeting we are going to leave, right? So it doesn't matter what the ambiguity is. Doesn't matter what the conditions are. You just don't do anything, and it will go away. Okay, it will go away. That's one thing that we are going to do. Just ignore it. Okay. Don't do that. Okay. The third one is probabilistic approach. I am going to find all the ambiguous meanings and I'm going to assign a probability to it. What is the most, okay, for you? When I ask you this question, mate or duck, which one did you think first? The first one, second one, third one. Okay, give me a number. First one, whoever think the first one. I cooked waterfall for yemesi için ördek yaptım. Kaç kişi bunu düşündü? One. I cooked waterfall belonging to her. Onun ördeğini ben yaptım. Yani yemesi, bir dakika. Onun elindeki ördeği ben yaptım yemesi için. Bunu kaç kişi düşündü? Bunu zaten düşünemedik, 0. Elindeki ördeği ben yaptım. Bunu kaç kişi düşündü? 3, 4. Taş attım kafasına doğru, kafasını içeri çekti. 1, 2, 3, 4. 4 de bu. Kafasına değnekle vurdum, ördeğe döndü. 7. So usually whatever probability I am assigning, it should assign the highest probability to this one. So how am I going to come up with this kind of a probability calculation? Are we going to ask this to the people? Well, that would be too unscientific, very difficult to do. We are going to find a way to do it. So highest probability is this, lowest is this one, but in probability, no occurrence, no event can have a 0 probability. It should have some kind of a probability. I mean, I bet if I had a classroom of 100 people, 1 or 2 people raise their hands. By the way, more than half of the class didn't raise their hands. I think they found another ambiguous meaning for this sentence, but they are not saying anything. So that's the second way of dealing with the ambiguity. We say that these are all the meanings and these are the probabilities. If I add up all the probabilities, it adds up to 1.0. Okay. The other one is a pipeline processing that ignores the ambiguity. Okay. And then it says that maybe it will be resolved later. First, I will do the morphologic analysis, MA. Then I do the syntactic analysis. Then I do the semantic analysis, and etc. But at the beginning, I will have the phonology analysis. Okay. Remember this phonology analysis here. These are all ambiguous and they are all acceptable in terms of phonetics. Okay. But only one or two of them will pass the syntax level. Okay. Phonetics says that these are the sentences that I am hearing. Okay. Then after that, the morphology and syntax says that, okay, I am ate or duck, the second one, is not acceptable. Okay, is not acceptable in terms of syntax. I am ate or duck is not acceptable. Some of them are acceptable, some of them are not. So I am passing in this pipeline 12 different meanings. Syntax level accepts only 3 of them. Okay, that's what it says. It says, okay, pipeline processing that ignores the ambiguity as it occurs, hopes that other levels can eliminate the incorrect structures. Okay, that's the, maybe you cannot read it very well because it is orange in my, can you read it now? Even worse. Well, just believe me, it says pipeline processing. Okay, and the first one is tightly coupled interaction. You don't do this kind of pipeline processing. Do the phonetics first, then the morphology, then the syntax. There is a loop between them, right? Phonetics says that I did this. The morphology says that I cannot accept it. Phonetics says that I am doing this, and there is an interaction. Okay, so all of them are all acceptable, but we like the last one, don't do anything, and the probability ones. Those are the ones that we are going to use most often. Okay, and it will be interesting to see what kind of probabilities we are assigning and where those probabilities come from. Okay, you'll be surprised that it is very simple but effective too. Okay, good. Any questions? That's how we are going to deal with the ambiguity. Okay, so let's move on. Let's talk about the tools that we are going to use in our NLP endeavors. Models and algorithms. Remember, I talked about the Newton's model for the motion of the objects, right? That was the model for the motion of the objects. Very simple, very effective model. And we are trying to find those kind of models to model how the words come together, okay? So by models, we mean the formalisms that are used to capture the various kinds of linguistic knowledge we need. Newton made lots of observations about the motions of the objects, and he came up with that simple model based on mathematics, okay? And we are making lots of observations about how we use the words and sentences, and we are coming up with the models. Before the computational linguistics, okay, all of these computers are invented, people try to model the language actually. They say that it is grammar, right? Grammar defined for English or grammar defined for Turkish, it existed a long time before the computers were invented. Okay? Linguistics is a very old field. It's a very old field. And people have been trying to model the language itself. So we can have some help from the linguistics literature. We can use their grammar rules. Okay, those grammar rules, some of them they teach us in our primary when we study Turkish or English at the primary school, secondary school, high school, even at the university. They try to teach us our grammar, right? Those Turkish questions in the university entrance exam, right? Most of them are about Turkish grammar. Which one is acceptable? Which one is not acceptable in terms of Turkish grammar? So they are measuring us how we know about our Turkish language. Which one is acceptable? Which one is not acceptable, etc. So we have already some models, but that doesn't mean that we could use our models to do the natural language processing, because it turns out that those models are not good enough, they are not precise enough, or they are complete. Okay, so we have to do something else about those models. And then we have algorithms. Once you have your model in your hand, okay, you can design algorithms around those models, and those algorithms will give you the final results once they are implemented. Okay, these are some of the model paradigms that we are going to use. State machines, for example, this one. If you have a word, okay, if this is the root of the word, kelimenin kökü, if you add a lar suffix to it, this is a singular root, then it becomes plural. Okay, it's a state thing. If you have a singular root and if you add I to the end, it becomes accusative format, i hali. Okay, it's a state machine, right? I have 1, 2, 3 states. For Turkish morphology, we can have thousands of states, different states, right? And starting from the noun root form of the word, we can move in this state machine, and depending on where we end up with, we can say that I analyze this word, the root is this, and it takes this suffix, and then this suffix, and this suffix, and this suffix. Okay, so that's a state machine. That's one model. We can model the whole Turkish morphology using this state machines, and in fact, I will give you an example, online example. Play with this example. This guy, Çöltekin morphology. This is online. Yeah, TR Morph. You just, I hope it didn't go down. Yeah, here it is. So you, for example, what was the halaları? Analyze it. Running this state machine, it says that I found this many different meanings. Hala is the root noun, then plural, okay, then possessive third singular. Halalar is the root, possessive third singular, onun halaları. Bir kişi. Bir kişi.
Bir kişinin iki ya da daha fazla alması.
Evet. Then hala plural, then accusative. İyi hali. Halaları. Halaları getirin. It is different than onun halaları, right? Halaları getirin. Okay. These are all different states that it can end up with. Some of them are not valid. This doesn't work very well. See this talks about hala. Okay, hala. Hala is adverb, zarf, right? Because it doesn't know the difference between şapkalı a and a. Okay, so this whole thing is built on top of the state machines. Then we have the rule-based approaches. Okay, rule-based approaches are if-else statements. If this happens, then this. If this happens, then that. If this and then that. And usually our grammars, classical grammars, are expressed that way, right? It is expressed that way. Logical formalisms, again, I am not going to talk much about it. They are very nice. They are very, I mean, long formalisms is coming from the 5,000 years ago, from Greek times and that kind of stuff. 5,000 is too much, 3,000 years ago. Okay, I'm going to skip that one. Probabilistic marvels are the models that try to assign probabilities to morphology stuff or the syntax stuff or the semantic stuff. Okay, and algorithms are usually whatever model you have. Okay, you try to make it more concrete in terms of an algorithm, and you implement it. Most of the time, our algorithms will be around transducers, okay, like a finite state machine. But unfortunately, since most of the stuff that we deal with are ambiguous, okay, algorithms and ambiguity don't go together very well. So what do we have to do? We have to find all the ambiguous forms of a given sentence, okay. So that makes our algorithms more complicated. Sometimes they run for a very long time, so we have some time complexity issues. Okay. Paradigms are like models. They are more general than models. State space search, dynamic programming classifiers. We are going to use these models. You know state space search, right? Maybe you don't. Let me try to draw a state space search. It's a very classical example. It's a very classical example for the state space search. Yeah, I am sure some of you saw this from me. 8 puzzle game. Okay, 1, 7, 3, 2, 4, 5. What is missing? 6. And what? Which one is missing? 8. 5 is here.
8, 9.
Yeah, 8. So, starting from this configuration, you want to reach to configuration where the numbers are 1, 2, 3, 4, 5, 6, 7, and 8. You can move this tile like that, or you can move this one like that. Okay, so there are 2 possibilities here. Either 5 will be at this corner, or 8 will be at this corner, right? Then if 5 is at this corner, there are 3 possibilities from there, right? So I started from this node, I come to these 2 nodes. From these 2 nodes each, I can go to 3 different possibilities, and that makes a space, right? This is called each one is a state, each node is a state, and this whole thing is a state space. If I make a search on the state space, and if I find this node, that's the solution. Then you will say that I am going to follow this route, and that will give me the solution, right? So that's called state space search. And AI people do this a lot. AI people do this a lot. And we are going to use state space search in some of our algorithms. Okay, that's one thing. The other one is dynamic programming, that paradigms that we are going to use. You know dynamic programming from CSE 321, right? Algorithms course. Or the graduate students 521. Dynamic programming says that if you are solving very similar problems, usually you end up solving the same problem over and over again. If you solve the solved problem, okay, don't solve it again. Keep it somewhere. Whenever you need it, you get the solution from that storage. Okay. So this idea is used a lot, and I'm going to give you the first example in our next lecture. Okay. So that's called dynamic programming. We are going to use it for edit distance, spelling correction. We are going to use it for syntax analysis. We are going to use it for machine translation. It is very useful thing. And by the way, dynamic programming is not only for NLP problems. If you learn its basics very well, you can apply it to many other problems. As long as your data is one-dimensional, like the sentences are one-dimensional data, right? As long as your data is one-dimensional, or it can be made into one-dimensional data, dynamic programming is applicable, and it's very useful, very, very efficient. Then we have our classifiers, machine learning based classifiers, either supervised or unsupervised classifiers, and we are going to use them too. Okay. I already gave you the example for the state space search. Okay. And as I said, we are going to, by the way, what is the, okay, tell me how many nodes does this space have? This is one of the nodes. This is the starting node of this space. How many possible nodes are there in the space?
9 factorial.
9 factorial? Is that true? Real? Yeah. Because each tile can be any other place, right? Yeah. I mean, let's try to fill this in. How many possibilities are there for this one? 9, right?
9.
Then 8, then 7, etc. So it is 9 factorial. 9 factorial is a very large number. This is a 3 by 3 board, right? And if I do 5 by 5 board, okay, it's going to be how much? 25 factorial. And I don't know how big 25 factorial is. It's too big. Okay. Why am I talking about this? The breadth of this search space, because it is too large. I mean, this is just a simple game, very simple game. Okay. If you apply this idea to the NLP problems, your space will be much larger than 25 factorial. Okay. So it's going to be straightforward implementation of the state space search is going to be problematic. What are we going to do? We need to trim the space. We need to ignore some parts of the space. We need to use lots of heuristics that we think they kind of work. Okay? So it would be nice if we find the perfect solution by searching over all the space. We would find the optimal solution. But remember what I said, we will never find the optimal solution for a typical AI problem. Okay? We are going to find good enough solutions. So we are not going to scan or traverse the whole search space. Okay? Exhaustively scanning the whole space is very, very expensive. So we need some heuristics. Okay, dynamic programming, we already talked about it. Don't do the same thing over and over. Okay, if you solve the problem, then keep it somewhere, and we are going to use it later. Sub-problems. Principle of optimality. Okay, good. That's kind of the introduction to what we are going to do and how we are going to do it. So as you see, it's a combination of computer science and linguistics. Okay, I'm going to tell you some linguistic information about the words and syntax and semantics and etc. We are lucky that we can both use English and Turkish at the same time for this course. I'm assuming that everybody knows Turkish in this in this course, because that makes it a lot easier to understand the ambiguities, because the same ambiguity cannot happen most of the time, of course, both in English and Turkish. It is easy to see the differences. The book, the Girafsky and Martin book, it gives, at the end of each chapter, it gives examples from other languages other than the English. For the most morphology part, his favorite language is Turkish, because Turkish is at the end of the morphology spectrum, most complicated language in terms of morphology, at least in the studies, analyzed languages. And in fact, he says that, what was his example? Uygarlaştıramadıklarımızdanmışçasına.
Muvaffakiyetsizleştiricileştiremeyebileceklerimizden dediklerimi.
He doesn't say that, no. I think what you are saying is not a valid Turkish word. It is not right. Uygarlaştıramayacaklarımızdanmışçasına is a valid one. Turkish Türk Dil Kurumu kabul ediyor bunu. He says that there are what 10 suffixes to this one, and he has a complete sentence on it. Just read the PDF. So at the end of each chapter about morphology or about syntax or semantics, they try to give examples from the other languages other than the English, and Turkish plays a role at the morphology chapter. The morphology part of Turkish is complicated, really, but it is solvable by finite state machines, actually, as I showed you. Well, I mean, this one doesn't tell you. See, when I say halaları, it says that these are the different morphological analysis of the word halaları. It doesn't say you should pick this one or that one or that one, right? This is not ambiguity resolution. Okay, it just says that these are all the meanings. Just take them, whatever you want to use, just use it. Okay, so solving ambiguity and finding all the ambiguous meanings, analysis ways, are different things. So coming back to this one, computer science plus the linguistics theory means natural language processing. It used to be defined that way maybe 10 years ago, but nowadays we started seeing stuff from deep learning that says that doesn't matter what kind of language you are using, doesn't matter what kind of grammar you have, doesn't matter what kind of morphology you have, if you run this algorithm, it will work for you. Okay, so most of the people that work on the Google's or Amazon's or Microsoft's NLP projects, machine translation projects, they don't know any language other than English. Okay, all they need is a corpora. Corpora is data set that involves human language. This is the text, Turkish text, this is the English text. They correspond to each other, and if I have gigabytes of data that corresponds to each other, looking at data, I can produce English text or Turkish text from the corresponding language, and it started being like that. So nowadays, as I said before, to do natural language processing, you don't need to know much about the language itself, the grammar itself, morphology itself, but I am not going to do that way. I will try to introduce you the ideas that were invented in 1990s, 2000s, 2010s, okay, to see what we were doing in terms of Turkish rules or the English rules, then what is new, okay? That would be a more complete coverage of this area, NLP, okay? That's what what I'm trying to do. Okay, I guess that will be it for this week. Next week we are going to continue from this point on. Are there any questions? Good, okay, thank you.